Right, today I've come, I'm not showing any engines, any oil filters and other things. Just want to delve into simple electronics, just the basic electronics. So what I want to do is to build parallel circuit, for the lighting systems. And we just want to see, look at a few principles concerning, parallel circuits. So I've got the board here. I've got the different components. I'll name them as we go. I've got the multimeter. I just need to connect it. Just need to connect it. Make sure it's on voltage before I blow it up. So what I'll do first, so this is our battery. So I'll fit the battery on, and I've got a voltmeter. Right, so I've got a voltmeter. I'll voltmeter as well. Then I have my ammeter. This is an ammeter. So I'll put my ammeter here. So these are part of like conductors. Let's see how we get on here. And I'll put my parallel circuits. Let me build my parallel circuits. I've got bulbs. They're the same resistance. So build there, and then we just do this quickly. Right, here we go. And remember, it's a parallel circuit. Next time we'll do a series circuit. And this is my switch. Take note of where I'm putting my switch. It's on the ground side. Okay, and this is my positive. That's my positive side. This is the ground side. So I've chosen to put my switch on the ground side. I can move it. I'll do the same circuit next time with the switch on the positive side. So I want us to see if there are any differences. So in the moment, here's our power. I've set my power on 6 volts. And if you want to zoom, our voltage is 6 volts. So we're not using 12 volts. So the circuit at the moment is off. All that I've just done is to put a voltmeter here in order to measure voltage, so that you know the amount of voltage that we're using. When it comes to our ammeter, because the circuit is open, the ammeter is 0. So what I'm going to do then is, if I close this switch, you can see now that the lights come on. If I let go, the light go off. Close, the lights come on. So check our ammeter as well and see now it's reading 0.8 of an amp. It's reading 0.8 of an amp. So if I go off, that's on, off, on. Right. So what I'm going to do now, I want to use, I know I've got a voltmeter here that is in the circuit already. So this is my ground side. So I'll put the ground lead here and I've turned the voltmeter to direct voltage. As you can see, this is direct voltage, this is AC voltage. So we want to measure DC. Okay, so remember we said we have 6 volts. So can we confirm that? Yeah. So 5.9, there is voltage drop in the connections, but roughly that's 6 volts that we have. So what I want to do, just simple things before I delve into the parallel circuits. So this is our positive side. So if you notice, I've moved from here to here. It's showing power on the meter. If I come next, it will still show the power. If I come here, we still see same voltage. I come here, I go there, right? I come here, there, that's still 6 volts, 5.9, 71. Here's the interesting thing. So the positive starts from here. That's our positive side. And it goes, of course, the ammeter has got to be connected in series with the circuit. So our positive goes through and it comes out here and it stops here and there and there. This side here, it's now our ground side coming to the ground here on the battery. Okay, but I want you to make an observation here. This is to help us, when we are diagnosing, problems on cars. So if I come here, right, I have 5.9. Look what happens if I come on the negative side of this bulb. I still have 5.9. I go there, positive, 5.9, 5.9, 5.9, and 5.9. The reason why we are getting voltage here, why we're getting full voltage, which is maximum voltage, we know that this bulb here, these 3 bulbs here, they are the load, and the load should consume all the voltage before it goes onto the negative side. Of course, some of it will trickle through anyway, but in this case we are getting full voltage. The reason is because we don't have a complete circuit. We do not have ground here, for the reason that our switch is off. So our switch is open. This switch is open. If that switch closes, then that voltage that you are reading here is gonna change, right? So let's close the switch first when we are on the positive side. So the switch is closed, we are on the positive side, and we have about 5.685 volts. So we are just, about 0.3, maybe 0.4 of voltage drop, right? If I open the switch, we go back to full voltage. Now, here, this is where the interesting part is. We have full voltage this side, okay? So let me close the switch. Let's see the difference now. So when I close the switch, this ground now is going to be applied on the ground side, because now we have ground. Otherwise, voltage flows and it stops at an open. And an open in this case is that switch there. So if we close this switch, you can see what has happened to our voltage. Now, our voltage is reading 0.1. We have 0.1 of a volt. Okay. So which is good for the negative side. I'm happy to see that on the negative side. All right. So remember that voltage will always stop at, it will always stop at the at an open, okay? And the other thing that I wanted to note here is that with a parallel circuit, let me do this here. With a parallel circuit, you will find that voltage is the same in every branch of that parallel circuit. So if I come here, we get the same voltage. If I come here, we get the same voltage. Okay, so from the source, we have just dropped about 0.5. It is just due to the connections. Okay, there are resistors in that ammeter there, and we have a voltmeter as well. Okay, but voltage will be the same in every branch of a parallel circuit. Take note of that. But the current that flows through each branch will now be determined by the resistance of the load itself. So that will depend on the resistance of the load. So if the load 1, 2, and 3 are the same, then the current is going to be the same. But if these ones are different, that will determine then that 0.8 of the current will be shared then among these 3. But if we come on the other side here and tap on the car and measure current, we'll get now the total current that is flowing in that circuit. So I hope this simple explanation, is going to help someone understand how simple electronics work. So I'll just go here and cap up. So this is a battery. This is a voltmeter. You notice the voltmeter is connected in parallel. You always connect the voltmeter across the battery, okay? But the ammeter, which measures current, it is connected in series with the circuit. You have to open the circuit in order to measure the current that is flowing therein. So what I said then about parallel circuits, lights that are in a parallel circuit, I said that voltage will be the same on every branch of the parallel circuit. Voltage will not change. What changes is the current. So in this case, these bulbs have got the same resistance. So that means then that current is going to be the same as well. But if these were different, you would find that if this one had a higher resistance than that one, so we would have less current then flowing through this branch here as compared to that one. But in this case, they are all the same. And take note what I said about the switch being on the ground side. Okay, I put the switch on the ground side. I will move this switch on the other side just to show you the difference, and then we will do the same measurements when the switch is on the positive side and see if we are going to see any differences. I hope this is going to be enough. I don't want to say a lot. This is just an introduction. So let's take it one step at a time. This is a parallel circuit for which voltage is the same in every branch of the circuit. Maybe one thing that I might want just to introduce before I go, then that which we will want to explore later on, is that the more parallel circuits you have, the less the total resistance of that circuit. So if we keep on adding, if now we've got 3, if we add the 4th one, you'll find that total resistance is going to change. And the other thing that I want to say as well is that if these were different, let's just give an example that this was 5 ohms, this was 10 ohms, this was 15 ohms. So let's say 5, 10, 15 ohms. The total resistance of a parallel circuit is less than the least of the resistors. So because we said 5, 10, 15, which means the total resistance in this case will be less than 5. So I'm just giving you these laws and principles of a parallel circuit so that we will explore them, in our next video. But at this time, I just wanted you to see how we build a parallel circuit and how we do the measurements. If you have any questions, just drop a comment and I'll be able to come back to you.